Welcome back to Universal Things. Imagine a force silently taking control of your life, nudging you faster every single minute. At first, it is a phantom whisper, a tiny 1 kilometer per hour addition to your pace. You will not feel it while sitting on your couch, but the cosmic clock has started ticking. Within an hour, you are moving at highway speeds without a car. How long could your body survive an exponential race against physics itself? Let us dive into the terrifying reality of endless acceleration. In the first 60 seconds, you gain a tiny boost of 1 kilometer per hour. If you are sitting down, this feels like absolutely nothing because human perception only registers changes in acceleration, not a low, steady velocity. But by minute 15, your baseline speed reaches 15 kilometers per hour. This is a brisk, athletic running pace. Even if you are trying to stand perfectly still to brush your teeth or drink a cup of coffee, your body is being forced forward. How would you even manage to stay inside your house? By the end of the first hour, the math catches up to you brutally. You are now traveling at exactly 60 kilometers per hour. This is the legal speed limit for cars driving through busy city zones. If you are inside your living room, you are now violently crashing through your walls, furniture, and windows. You have officially become a human projectile. To survive this initial phase, you would need to abandon your home immediately and head to a massive, completely empty, flat landscape. Where would you run to? 5 hours into this experiment, your speed skyrockets to 300 kilometers per hour. This is the blistering top speed of a high-speed bullet train or a Formula One racing car. At this point, human biophysics begin to break down under the sheer pressure of the environment. The wind resistance hitting your face is so incredibly intense that you can no longer inhale oxygen normally. Your eyes are forced shut by the wind. If you do not have specialized racing gear and a helmet right now, you will suffocate. As we cross the 12-hour mark, you are screaming across the landscape at 720 kilometers per hour. You are now moving at the cruising speed of a commercial Boeing passenger jet, but you are doing it with your bare feet planted firmly on the ground. The friction between your shoes and the earth generates extreme, localized heat. Normal rubber and leather will instantly melt away, leaving you exposed. What kind of advanced material would you wear on your feet to survive this insane amount of friction? At our 24, one full day has passed, and your velocity hits a staggering 1,440 kilometers per hour. You have officially shattered the sound barrier, which sits around 1,235 kilometers per hour. As you breach this threshold, you trigger a massive, continuous sonic boom that follows you everywhere. The shockwave is so violently loud that it instantly shatters your eardrums and blows out the windows of every single building you pass. You are now a walking, supersonic weapon of mass destruction. By day 3, your velocity climbs to 4,320 kilometers per hour. At this point, traditional concepts of geography completely vanish. You can cross the entire continental United States from New York to Los Angeles in less than an hour. But a massive engineering problem arises, the curvature of the Earth. Because the planet curves away beneath you, moving this fast in a straight line means you will literally launch off the ground into the atmosphere. How could you possibly force yourself to stay down? On day 7, you are traveling at an unbelievable 10,080 kilometers per hour. You are now moving fast enough to circle the entire globe in just under 4 hours. The atmospheric drag against your body acts like a furnace. The air molecules in front of you cannot move out of the way fast enough, compressing violently and generating thousands of degrees of heat. Your skin would burn instantly without a spacecraft's thermal shielding. Could human technology ever build a suit to withstand this? By day 11, your speed reaches 15,840 kilometers per hour. You are now rapidly approaching what physicists call low Earth orbit velocity. The upward centrifugal force created by your speed is starting to perfectly balance out the downward pull of Earth's gravity. You will begin to feel completely weightless, bouncing thousands of feet into the air with every step you take. You are no longer running on the planet. You are skipping across the top of the stratosphere like a stone on water. Day 20 arrives, and your speed hits 28,800 kilometers per hour. This is the exact speed required to permanently break free from Earth's orbital gravity. You can no longer stay on the planet even if you want to. You are flung violently out into the cold vacuum of space, trailing a faint cloud of evaporated atmospheric gas behind you. The Earth quickly shrinks into a blue marble beneath your feet. You are now an independent celestial object traveling through the solar system. What is your next destination? 1 month into the journey, your speed is an astronomical 43,200 kilometers per hour. You are blazing past the orbit of the moon in just a matter of hours. In space, there is no atmospheric friction to burn you up, which is a massive relief, but you face a new danger: micrometeoroids. Even a tiny grain of space dust hitting you at 43,000 kilometers per hour carries the kinetic energy of a hand grenade. A single collision would instantly obliterate your entire body. By month 3, you are traveling at 129,600 kilometers per hour. This makes you significantly faster than the Voyager 1 spacecraft, which is the fastest human-made object ever sent into deep space. You quickly cross the orbits of Mars and enter the dangerous asteroid belt. Navigating this zone requires intense mathematical luck. Because your speed increases by 1 kilometer per hour every single minute without fail, your kinetic energy is multiplying exponentially. What happens if you collide with a massive asteroid? 6 months in, your speed crosses to 159,200 kilometers per hour. You are now moving so fast that the gravitational pull of the sun can no longer hold you within the solar system. You are officially entering interstellar space, the vast, dark, empty void between the stars. The solar system fades into a distant point of light behind you. Space is incredibly lonely and freezing cold, hovering just above absolute zero. How would your mind handle months of absolute silence and pitch-black darkness? By the end of year 1, the constant accumulation of speed brings you to 525,600 kilometers per hour. At this rate, you are covering millions of kilometers every single day. The stars ahead of you begin to shift slightly in color due to the relativistic Doppler effect, turning a deep, vibrant blue as you rush toward them. Time dilatation, predicted by Albert Einstein's theory of relativity, is technically starting to occur, though it is still far too small for you to actively notice. Let us fast forward 5 years into this mind-bending experiment. Your speed has now reached a colossal 2.6 million kilometers per hour. You are traveling at nearly 1% of the speed of light. At this unimaginable velocity, the hydrogen atoms floating in the vacuum of interstellar space turn into a deadly wall of intense radiation. Passing through them is like standing in front of a continuous, high-energy particle accelerator. You would need cosmic shielding just to keep your DNA intact. By year 10, your velocity scales up to 5.2 million kilometers per hour. You are now crossing entire star systems in mere days. If you directed your path toward Alpha Centauri, the closest star system to Earth, you would arrive there in just a fraction of a human lifetime. The universe is becoming a blur, but remember the core rule of this scenario: the speed never stops increasing. You are trapped in a permanent cosmic acceleration that you have absolutely no power to slow down or halt. At year 50, assuming your body is somehow preserved by cosmic forces, your speed reaches 26.2 million kilometers per hour. You are now traveling at roughly 0.4% of the speed of light. Now, Einstein's theory of relativity officially takes the driver's seat. Time is moving noticeably slower for you than for the people left behind on Earth. For every year you experience out in deep space, multiple years are passing back home. You are actively traveling into the future. 100 years into the experiment, your speed hits a mind-melting 50.5 million kilometers per hour, which is nearly 5% of the absolute cosmic speed limit. At this velocity, the interstellar medium begins to compress so intensely in front of you that it glows with brilliant, blinding Cherenkov radiation. You look like a blazing meteor tearing through the cosmic web. You are moving fast enough to escape the gravitational pull of our entire Milky Way galaxy. Let us push the experiment to 500 years. Your speed has reached 260.8 million kilometers per hour, crossing 24% of the speed of light. The visual universe around you begins to distort into a strange, surreal optical phenomenon known as relativistic aberration. The stars beside and behind you appear to bend forward, crowding into a single, intensely bright, circular window right in front of your eyes. The cosmos is literally reshaping itself around your speedle. At 1,000 years, your velocity scales up to 525.6 million kilometers per hour, which is roughly 48% of the speed of light. Time dilatation is now severe. Your internal clock is running significantly slower. While you experience a single heartbeat, days or weeks might be passing in the outside universe. You are witnessing the birth and death of stars in fast forward. If you could send a radio message back to Earth right now, what would your final words to humanity be? What happens when you hit 100% of the speed of light at year 2061? Physics states it is completely impossible for matter to reach this limit because it requires infinite energy. If the universe forces you to cross this boundary anyway, the fabric of space-time itself might tear apart around you. You could collapse into a localized black hole of pure kinetic energy, or perhaps you would transcend our three-dimensional reality entirely. What do you think would happen? If you somehow bypassed the light speed barrier and entered tachyonic speeds, physics flips entirely upside down. You would begin moving faster than light, meaning you would arrive at your destination before you even departed. You would be traveling backward through time, witnessing the history of the universe unravel in reverse. You could watch galaxies burn, stars explode, and the solar system piece itself back together. It is a realm of pure mathematical chaos. This simple concept of adding just 1 kilometer per hour every single minute starts as a minor inconvenience in your living room, and ends by completely shattering the fundamental laws of the universe. It shows just how fragile our reality is when pushed to mathematical extremes. From breaking windows with sonic booms to breaking the cosmic speed limit of light, physics always finds a way to blow our minds. Which phase of this terrifying acceleration surprised you the most? If this cosmic journey blew your mind, smash that like button right now and leave a comment with your wildest theory on what happens when you break the speed of light. Share this video with a friend who loves science, and subscribe to Universal Things for more mind-bending videos just like this. Don't miss our next thought experiment. Make sure your notifications are turned on so you can join us on the next wild ride across the universe. See you in the next video.